Good morning, students. We'll start with the today's lecture. Yesterday we have seen the theoretical aspects of Nyquist plot analysis, right? And what we have studied, that I will brief you out. Next slide I have summarized it. Right, today what we are going to study, Nyquist stability criterion. What is Nyquist stability criterion, that we will see. Then what is the general Nyquist path and how we can map from S plane to F plane, right? That also we will see. Then steps to solve the problem by Nyquist criterion, and we'll solve one of the numerical on the Nyquist plot, right? Okay, yesterday we have seen the Nyquist plot analysis step by step. First, we have analyzed the pole zero configuration from Nyquist plot point of view, right? And we have defined the function f of s, right? That is equal to 1 plus g of s into h of s, right? So the zeros of this function are nothing but the closed loop poles of the system. The zeros of this function f of s, that is 1 plus g of s into h of s, are nothing but the closed loop poles of the system that we have seen, right? Then the open loop poles remains the same in both the cases. Then concept of encirclement, that we have seen, right? The number of encirclements that we have seen. Then what is analytic function, what is single valued function, what is non-analytic function, what are the singularities of the function, that we have seen. Then mapping theorem we have seen, that is n equal to the number of encirclements of origin z minus p, right? So this we have seen, the also called as principle of argument, and this mapping theorem forms the basis for a Nyquist stability criterion, because we will take, means this z represents the number of zeros that are lying in the right of the s plane for stability. So z should be 0. So this Nyquist stability criterion n is equal to minus p. This we have seen, right? Yesterday all those things we have studied. Next we'll start with the today's lecture. uh, general Nyquist path and its mapping. How to choose the selection of Nyquist path is very important. We'll see how to choose the Nyquist path. You can observe here in the first diagram. This is the first diagram, right? So you can observe here S is plus j infinity here. From plus j infinity it is moving towards minus j infinity. Means entire imaginary axis is covered, right? Then from minus j infinity, the radius of the semicircle is infinite. The radius is infinite. You can see here the radius is infinite, and from minus j infinity to plus j infinity it is connected. Means this Nyquist path or closed path or contour is enclosing entire right of S plane, right? So Nyquist path is covering entire right of the S plane, right? So this path is covering, if any of the zeros are lying in this right of S plane, we will come to know, right? So this is the Nyquist path is selected. Suppose, okay, in second diagram you can observe here, this is also a Nyquist path, but slight changes are there from first diagram to second diagram. I will tell you what are the changes. Suppose the poles are located here on the imaginary axis at plus j omega 1. One pole is located and another pole is located at the origin here. Then one more pole is located at the imaginary, on the imaginary axis, minus j omega, right? Minus j omega 1, right? Let me take it, minus j omega 1. Okay, so the two poles, there are three poles lying on imaginary axis, plus j omega 1, minus j omega 1, and at origin, right? The three poles are lying, but I cannot take the same Nyquist path for the poles lying on the imaginary axis and the pole lying at origin. So what I will do, so I will start my Nyquist path from plus j infinity. So this pole is coming, right? Plus j omega just above this point and below this point. So I will go, I will make a semicircle whose radius is almost 0. Means I am getting at the same point. So I will bypass this imaginary pole. So start from plus j infinity, same as this, and I should go to minus j infinity, right? So here it is coming to minus j infinity after bypassing all the poles and zeros. Here it will plus j infinity, it is bypassing this plus j omega 1. Once again it will come here, it will bypass this pole at origin, it will bypass, and one more pole is there, it will bypass here, and it will come to minus j infinity, and it covers the entire right of S plane. The radius of this bypass, right, it is bypassing this uh, pole lying on the imaginary axis. This Nyquist path is bypassing the pole lying on the origin, pole lying at the origin, and this Nyquist path is bypassing the pole lying on this imaginary axis, right? But it is covering entire right of S plane. Why we are bypassing means we have defined that the each and every points on the Nyquist path should be analytic. Analytic means it should have finite value, but for the poles and zeros, they are not the. If I substitute poles and zeros, then the function will be non-analytic, so we should bypass. I hope you are getting. Okay, this is the second bypass, sorry, second Nyquist path. How to select? Suppose, let me go for the third scenario. How to select? Suppose there is only one pole at the origin. One pole is at the origin. One pole at origin. Then how to select the Nyquist path? So select Nyquist path in the S plane, right? So there is one pole at the origin. So let me take this sigma j omega, right? So there is one pole at the origin here. So the Nyquist path starts here plus j infinity. It will move towards minus j infinity, right? So let me take the Nyquist path here. I'll change the ink color. You can see here. So the Nyquist path starts here and it will come towards this pole lying at origin. Sorry. Okay, fine. Okay. Then bypass this 0, right? So and it will approach towards minus j infinity. So this is the direction. I hope you are getting. Then the radius, it will form a huge semicircle whose radius is infinite. D shape it should come, D shape, right? So it will go here like this. So whose radius is infinite, right? This radius is infinite from here to here. The radius is infinite. So r tending towards infinity, and radius of this semicircle, small semicircle, r tends towards 0, right? So this is the Nyquist path. So how to select Nyquist path? Whenever there is only one polar origin, this is the Nyquist path. I hope you are getting. This is the third diagram. Okay, this in the second diagram you can observe there is one of the pole here on the imaginary axis, so we are bypassing here. There is pole at origin, so we are bypassing here. So there is one more pole on the imaginary axis, we are bypassing here, and this is the Nyquist path. So here none of the poles are lying on imaginary axis, so then this is the Nyquist path. And Nyquist path, you can observe here how many sections are there in Nyquist path. We'll try to analyze. So you can observe here plus j infinity to 0. So this is, let me call it as section 1, plus j infinity to 0. From 0 to minus j infinity, section 2. We will divide it into sections, right? From minus j infinity to plus j infinity, third section. In this case, I hope you are getting, right? How many sections are there? So starting frequency is plus j infinity, right? Omega, yes, j omega. What is omega here? Infinity plus j omega, right? So j 0. So omega equal to infinity, omega equal to 0 here. This is first section. And the terminating point, this is the starting point of the first section, and this is the terminating point of the first section. So plus j omega, omega equal to infinity here, frequency, right? And here omega is 0 because it is 0 right here, right? So omega is 0. This is the starting frequency, starting point, and this is the terminating point. So I can draw the polar plot for the first section, right? So that there is a mapping from S plane to F plane, right? So I can draw the polar plot, because after drawing the polar plot of all the sections, I will get the Nyquist plot. So we have learned a polar plot. Hence I told polar plot is the basis for the Nyquist plot, right? So first section. Let us come to the second section. So since it is a mirror image, no need to draw the polar plot for second. It is mirror image. Whatever the polar plot I am getting, just take the mirror image about the real axis. So no need to do here in this case. So but let me try to analyze what is the starting point here. The terminating point of the first section will be the starting point of the second section. So omega equal to 0 here, and what is omega here? Omega equal to minus infinity for the second section. For third section, this is the last section. So starting point is omega equal to minus infinity, and terminating point is omega equal to infinity. So for last section, no need to draw the polar plot because it represents the origin in the Nyquist plot. Please try to understand my words. So there is no need to draw the polar plot for the last section, third section, because it represents the origin in the Nyquist plot. So anyhow it is origin, right? So that we'll see next. Then right now we are dividing into several sections. Let me come to the second diagram. How many sections are there? We'll try to analyze. You can observe here from here to here, this is section 1. From here to here, this semicircle, this is section 2. From this to here, section 3. And this semicircle, section 4. This straight line here, section 5. Then semicircle here, section 6. From here to here, it is section 7. Then this big semicircle, this is section 8. Totally 8 sections are there. Right here, 8 sections are there. So we have to draw the polar plot for each and every section. So here plus j infinity 2, here plus j omega in 1 is there. Right, this is the pole. Just above this point, let me take this point as plus j omega 1 plus. Just to differentiate, I should, so plus and minus, plus j omega 1 above, but let me call this, indicate it as plus because it is above, plus j omega 1 minus because it is below this point. So just notation we are using, plus j omega 1 plus and plus j omega 1 minus. Then let us come to this pole lying at origin. So above point let me call it as plus j0, below point minus j0, right? The radius of this semicircle is almost tending towards 0. Then let me take this pole, it is minus j omega 1, above point let me call it as minus j omega 1 plus, below point minus j omega 1 minus, just to differentiate, right? So there are totally 8 sections we have identified here, right? So first section, we have to draw the polar plot. First section, what is the starting frequency? Omega is in plus infinity, j omega, right? Then what is the omega here? Omega equal to omega 1 plus, right? Omega 1 plus or omega 1, simply I will say omega 1. Is it fine? Omega 1 plus. For second section, starting point is the terminating point of section 1 is starting point for section 2. This is section 2, semicircle. So frequency here, starting point frequency is omega equal to omega 1 plus and terminating frequency is omega equal to omega 1 minus. I hope you are getting. Similarly, section 3, section 4, section 5, section 6, section 7 and section 8. But if I draw the polar plot for section 1, section 2 and section 3, that is sufficient. Okay, section 4 also is required. And section 5, you can observe here, section 5 is mirror image of, let me take another ink. Section 5 is mirror image of section 3. Section 5 is mirror image of section 3. So whatever the polar plot I am getting for section 3, it is symmetrical about the real axis. So I will not analyze for section 5. For section 6, it is same as section 2. Section 6 is mirror image of section 2. Then next, come to the section 7. It is mirror image of section 1. Section 7, right? So I will draw the polar plot for first section, second section, third section and fourth section. But fifth, sixth and seventh. Fifth is mirror image of third section. Sixth is mirror image of second section. Seventh is mirror image of first section. And I told last section, 8, this one. This one is the last section. No need to draw the polar plot for the last section because it represents the origin in the Nyquist plot. Please try to understand, right? Okay, we'll see it. Then what is Nyquist stability criterion? Already we have seen. So n equal to z minus p. This is the mapping theorem or principle of argument. Mapping theorem we know. R also called as principle of argument. But for stability, z should be 0 because the zeros of the function f of s equal to 1 plus g of s into h of s, right? It should be 0. None of the zeros of the function f of s should be in the right of the s plane, right? So then only the system will be stable. So z is 0 means n equal to minus p. This is the Nyquist stability criterion. Nyquist stability criterion, right? So n equal to minus p. We will see this, how to use this. Then let us come to this third diagram. How many sections are there? We will identify here, right? So this is 0, right? So above one, let me take it as plus j0 minus j0. Let me take it like this. Is it fine? So this is the first section and this semicircle is the second section and this is the third section and here this one is fourth section. So section 1 and section 2, I will draw the polar plot for section 1 and 2, but section 3 is mirror image of section 1. Section 4 represents origin in the Nyquist plot. So you came to know how to choose the Nyquist path based on the location of the poles on the imaginary axis. If there are none of the poles or none of the poles lying on imaginary axis, then I will be choosing this Nyquist path. And if there are poles and lying on the imaginary axis, I will be choosing this Nyquist path. If there is only one pole at the origin, I will be choosing this Nyquist based on that, right? You just bypass it, that's all. So selection of Nyquist path, I hope there is no confusion. So just next, generalized Nyquist path and its mapping. Just I told for this figure 2. How many sections are there? I told section 1, section 2, till section 8. The same thing has been listed out in this diagram. Section 1, starting point is s equal to plus j infinity and ending point is plus j omega 1 plus. I already have told you. Here plus j infinity, here it is plus j omega 1 plus, right? I hope the same thing they have listed along. Similarly, section 2 till section 8, they have listed all these things. So identifying sections of Nyquist path, yes, over, that is over. Selection of Nyquist path first. After selecting the Nyquist path, we have to identify the sections of the Nyquist path, that is also over. The next third step is draw the polar plot for various sections. Mapping means if I am drawing the polar plot for various sections, means it is nothing but mapping these sections to F plane, from S plane to F plane mapping, right? How to map S plane to F plane already we have seen in the previous yesterday's class, right? So if I draw the polar plot for several sections, there are totally 8 sections here, right? 8 sections for this diagram, you can observe here. So once 1 2 3 4 5 6 and 7 8, 8 sections are there. Draw the polar plot for all the 8 sections, for example with respect to that Nyquist path. Means if I am drawing polar plot, means it is as good as I am mapping these sections to F plane, right? So let me see here. Yes, we have the function f of s, that is, let me take it as g of s into h of s. So we have assumed for Nyquist plot f of s, earlier we have taken f of s is equal to 1 plus g of s into h of s. So let me take only open loop transfer function f of s, means it is g of s into h of s. One we are not taking, right? This earlier we have taken. If you have taken the Nyquist stability criterion is n equal to z minus p, the number of encirclements of origin. But if I take f of s equal to g of s into h of s, n equal to just minus p, the number of minus p, the number of encirclements of the critical point minus 1 plus j0, because this one we are discarding it, right? So this is the critical point. I hope you know the differences from the previous discussion yesterday what we have seen, right? So the open loop transfer function g of s into h of s is equal to f of s. In frequency domain, replace s by j omega, that is g of j omega into h of j omega. Okay, how many sections are there? If I consider the third Nyquist path, totally 8 sections are there. For first section, let me take one by one. For section 1, what is the starting point? S is plus j infinity, and terminating point S is plus j omega 1. So starting point of frequency plus j omega, omega is plus infinity. Then observe this, omega is omega 1 plus. Starting point we came to know, terminating point we came to know. Then we know how to draw the polar plot. Get the magnitude equation, phase equation, get the rotation of the plot, and draw the polar plot for section 1. That is over. Similarly, you have to do for section 2. We identify the starting point, terminating point, rotation plot, and draw the polar plot for section 2. Next, go for section 3, section 4, and do all the things, right? After mapping all the sections, we will get a closed plot, right? Because there are several polar plots for each and every section. If we combine all those polar plots of all the sections, we will get a closed plot that we call it as Nyquist plot, right? Okay, once we get the Nyquist plot, what to do? We have to judge the stability. How? We'll see. Now count the number of encirclements of the critical point, whether how many times the Nyquist plot is enclosing this critical point minus 1 plus j0. That we have to check it. How? That is by the stability criterion n equal to minus p, right? If the number of encirclements n is equal to minus p, then I'll say the system is stable, because this is the stability condition, n equal to minus p. This p indicates the number of open loop poles which are lying in the right half of the S plane of the given open loop transfer function g of s into h of s. We will solve a numerical, you will understand very clearly all those things, right? Okay, draw polar plot for all the sections I told, but no need to draw the polar plot for section 5, 6, 7, because already I told they are mirror images of 3 to 1 respectively. Already I shown there. 5, 6, 7. The sections are mirror images of 3 to 1. Here I have shown you. 5, 6, 7. They are mirror images of 3 to 1. I have shown you, right? Green color. The same thing has been told here. Hence, their mapping in F plane is also mirror image about real axis. Right? If I know the polar plot of section 3, I can get the polar plot of section 5 because it is mirror image. If I know the polar plot of section 2, it is for section 6, it is mirror image. The same thing for 1 and 7. The last section, 8th, it is no need to draw the polar plot because it represents the origin in the Nyquist plot. So there is no need to analyze the last section, 8th section. Please keep in the mind all those things. Using this, we will draw the Nyquist plot and judge the stability of the system. So we came to know that joining all the polar plots of all the section one after the another, we will get the mapped locus. That locus or closed locus, we call it as Nyquist plot, right? And we will get the number of encirclements and the stability criterion n equal to minus p. Already I have told here, right? The same thing has been discussed once again here. Then calculation of gain margin, phase margin from Nyquist plot is exactly similar to the calculation of gain margin, phase margin what we have seen in the polar plot, right? We have seen how to calculate GM, PM, omega GC, omega PC from polar plot, right? The same thing applies here also, right? Okay, we will see the steps to solve the problem by Nyquist criterion. So first step is count how many number of poles of the function g of s into h of s are lying in the right half of the s plane, right? So what is p? We have to calculate what is p here. Suppose the transfer function is like this: g of s into h of s is equal to 2 divided by s plus 1 into s plus 2. For example, so you equate the denominator terms to 0. So what are the poles? S equal to minus 1 minus 2 means p is 0 here, because none of the poles are lying in the right half of the s plane. S is equal to minus 1, s equal to minus 2. Minus 1, minus 2 are the poles. They are lying in the left half of the s plane. But this, what is this p? It will give the information about how many number of poles are lying in the right half of the s plane. If I take this open loop transfer function, p is 0 here. If I take this example, this is one example, right? I hope you are getting. Then next, we know the stability criterion, Nyquist stability criterion, n equal to minus p. Suppose if I take this transfer function only, p is 0 here, and n equal to minus p means what is p? P is 0. So n equal to 0 I will get. If I take this example, I am telling, I am proceeding with this example. I am telling you, right? So for the system to be stable, the number of encirclements of the critical point minus 1 plus j0 should be 0. Means it should not encircle. The Nyquist plot should not encircle this point. Then only the system will be stable. If I am getting n equal to some value at the last, if it is enclosing means then system is unstable. If it is not encircling, it is stable for this particular example what I am taking, right? Then next, select the Nyquist path. We know how to select the Nyquist path. Diagram 1, 2, 3 I told how to select the Nyquist path. After selecting Nyquist path, identify the sections, then draw the polar plot of all the sections. Fourth step is draw the polar plot of all the sections. After drawing the polar plot, the polar plot has to intersect the negative real axis, right? So if it is intersecting negative real axis means we know how to find out mathematically omega pc, right? Whenever the polar plot crosses the negative real axis, that corresponding point we call it as q. At that point, corresponding frequency is phase crossover frequency omega pc. So first calculate omega pc and right, by rationalizing all those steps already we have done in the Nyquist plot, polar plot. How to calculate this omega pc mathematical, one of the numerical we have solved. The same thing we will see here also, right? And after finding out omega pc, then find out the intersection point on the negative real axis. That intersection point coordinates also intersection of Nyquist plot with negative, that point also we have to find out. Find out omega pc and intersection point also, both. Then after having all this, from step 4 and 5, go for drawing the sketch the Nyquist plot. After sketching the Nyquist plot, just look at the Nyquist plot whether how many times the Nyquist plot is encircling this critical point minus 1 plus j0, right? Let me, I will get n equal to something, some value, dash, some value I will get. Whether this value maps with the criteria described in step 2. For example, for this example, n should be 0. If I am getting n equal to 1, it is unstable. If I am getting n equal to 0, it is mapping with the step 2 stability criteria, hence system is stable, right? Based on that we have to judge. So these are the steps. I hope you understood less. I think if I solve the numerical, you will understand very clearly. I will follow these same steps, right? So step 7, once again it has been listed here, right? Step 7, the number of encirclements we'll find out. Then we can find out gain margin, because you know that, let me take, I'll tell you. Okay, let me draw the unit circle first, then only you will understand. This is the unit circle. Unit circle means here it is minus 1 plus j0, minus 1 plus j, this is the critical point, this point, right? Let me assume that the polar plot is crossing like this. Let me assume it is like this, omega equal to 0 and omega equal to infinity. So it is intersecting, then this is 0 degree, minus 90 degree, minus 180 degree, minus 270 degree. So the polar plot is intersecting the negative real axis at this point. We will call this as q, and the corresponding frequency at this point we call it as omega equal to omega pc. That only we are told, omega equal to omega pc, we have to calculate mathematically, right? And the point, what is the coordinates of this point q? It is minus sigma plus j0. So we want to find out what are the coordinates, right? The imaginary part anyhow it is 0. We have to find out the coordinates where it is intersecting, right? And this is origin from O to Q. So how to calculate gain margin? Gain margin is equal to 1 by magnitude of length O to Q. Means this distance from O to Q, this distance. So this is the gain margin. But if I want in decibels, take 20 log of this quantity. 20 log of 1 by magnitude of it will give in decibels. If the system is stable, I will get gain margin as positive. If the system is unstable, I will get gain margin as negative. Right? The simple thing. So I will not calculate phase margin, all those things. Right? This is sufficient. Okay. We will take one numerical. Please try to understand. I will solve very slowly and you try to understand. Right? Okay. A unity feedback control system. G of s is equal to 10 divided by s into s plus 1 into s plus 2. Draw the Nyquist plot. Yes, we will draw the Nyquist plot and comment on the closed loop stability. Observe this term, closed loop stability. Okay, we'll try to understand, we'll solve it. So this is open loop transfer function. G of s into h of s, if it is not given means h of s is 1. It is unity negative feedback, right? So h of s is 1. So since unity feedback, right? So h of s, so they are not writing h of s, or else you can write, no problem. So this is given. So first step, what is first step? How many poles are there? So you can see here s equal, so poles are located, let me look at the poles. Poles are at s equal to 0. So I equate the denominator terms to 0. S equal to 0, s equal to minus 1, s equal to minus 2. So the poles are located at 0, minus 1, minus 2. Then what is P? Number of poles. This capital P represents the number of poles which are lying in the right half of the S plane. Look at the poles 0, minus 1, minus 2. They are not lying in the right half of the S plane. Means P is 0. None of the poles are lying in the right half of the S plane. I hope you are getting. None of the poles are lying in the right half of the S plane. One pole is at origin. Remaining two poles are in the left half of S plane. But none of the poles are lying in the right half of the S plane. So we are taking P to be 0. This P tells us the number of open loop poles lying in the right half of S plane, right? Suppose if it is plus 1 plus 2, suppose let me assume the poles are 0, plus 1 plus 2 means 2 poles are lying in, so we will take P equal to 2. In this problem, all the poles are lying in left half of S plane, none of the poles are lying in the right half of the S plane, so P is 0. Step 1 is over. Identify. In step 1 what we will do, we will look at the number of poles lying in right half of S plane. Here none of the poles are lying in right half of S plane. Is it fine? Then next, we will go to step 2. Nyquist stability criterion. Nyquist stability criterion. So for system to be stable, what should be the condition? Nyquist stability criterion, n is equal to minus p. For the system to be stable, n should be equal to minus p. But here in this problem, p is 0, we know it. So I'll write n equal to 0. I'll not write minus 0, right? N equal to 0. So if the system has to be stable, the number of encirclements of the critical point means n is 0 means there should not be any encirclement. Then only the system will be stable. So this is the stability criteria right now. The next step 3, what to do? Select Nyquist path. Select Nyquist path. So how to select the Nyquist path? Observe the poles here. At 0, yes, there is one pole lying at the origin. Remaining this minus 1, minus 2, they are in the left half of the S plane, don't worry. But there is only one pole lying at the origin, so I have to bypass this. So we have to choose the Nyquist path. I will draw the Nyquist path here, observe. So the pole is lying at 0, this one. We are not, okay, this is at 0. And we are not worried about the poles lying at minus 1 and minus 2. Sigma j omega. Okay, let me, no need to change the ink, but let me choose it. So this will start at plus j infinity and it will move towards 0, but it has to bypass because there is pole at origin. If there is no pole at origin, it is just straight line. It will come to minus j infinity. So bypass it, right? This is the direction. It is coming to minus j infinity. Then draw the semicircle. This is plus j infinity, right? This is the direction. So this is the Nyquist path, what we have selected. select Nyquist path, right? This is the Nyquist path. Okay, what is the radius? Let me draw it. Let me, from here to here, this radius is tending towards infinity. What about this small semicircle? This radius tends towards 0. The radius of this small semicircle is 0. The radius of this big semicircle is infinity. Means it is covering entire right half of S-plane. This Nyquist path has to cover entire right half of S-plane, right? But only one thing is it is bypassing this pole lying at origin, because if I take the pole, it is not a singular point. The function will will become infinite. So we have to bypass this. So we are bypassing. How many sections are there? We will identify. Section 1, right? Section 2 and section 3. Sorry, section 2 is here, this semicircle. Then section 3, this from here to here. The next section, 4 sections are there. I hope you are getting how to select the sections, right? Section 1 plus j infinity to, let me take it as above, just above this point, plus j0. Let me take green ink only. Plus 0 is here, plus j0. Below this 0, it is minus j0. I hope you are getting. Then minus j. Section 1 plus j infinity to plus j0. Section 2 plus j0 to minus j0. Third section minus j0 to minus j infinity. Fourth section minus j infinity to plus j infinity. 4 sections we have identified. Then what is step 4? Nyquist path is selected. Draw the polar plot of all the sections. Right? Step 4. We'll go to step 4. Step 4. Draw the polar plot. Draw the polar plot of all the sections. Here all the sections means 4 sections are there. Section 1, section 2, section 3, section 4. So draw the polar plot of all the sections. Let me take the first section, section 1. Section 1. So what is starting point? Let me write it as starting point SP. So starting point is plus j infinity and terminating point, so it is plus j0. Right? SP means starting point, TP means terminating point. So I look at here, plus j infinity is the starting point and terminating point is plus j0. Is it fine? Then next, we know how to draw the polar plot for section 1. So let me make a table. Starting point, terminating point. Starting point, what is the frequency? What is omega? Starting point plus j omega, omega equal to plus infinity. And terminating point plus j omega, omega equal to plus 0. Terminating point, omega equal to plus 0. Right? This is the frequency. Right? Okay, before making this table, I should get magnitude and phase equations, right? So let me complete this table later. So I should have taken later. So replace S by j omega, g of j omega into h of j omega. So what is g of s into h of s? Let me write it here. G of s into h of s, what they have given. So it is 10 divided by s into s plus 1 into s plus 2. 10 divided by s into s plus 1 into s plus 2. Right? Replace s by j omega. So I replace 10 divided by j omega into 1 plus j omega. Just I am reversing 2 plus j omega. So I replaced s by j omega in this, right? Now it is in frequency domain. Next, get the magnitude m. So magnitude is, so magnitude of j omega into h of j omega. Get the magnitude equation. So it is 10 plus j0, under root of 10 square plus 0 square. It is 10 only, numerator. Magnitude is 10. So this one, magnitude of j omega, 0 plus j omega, under root of 0 square plus omega square. So it is omega. Next, under root of 1 square plus omega square. 1 square plus omega square. Next, under root of 2 square is 4 plus omega square as it is. So this is magnitude equation. Next, get the phase equation. Angle of g of j omega. You know how to calculate magnitude and phase, so I am not stressing much. If you are having doubts, you can ask. Unmute yourself and talk to me so that I can tell once again. Next, look at this equation, angle of 10 plus j0. 10 plus j0 means it is located on the positive real axis. 10 plus j0, angle of 10 plus j0 is 0 degree. Then angle of j omega, it is on imaginary axis, it is 90 degree. Next, angle of 1 plus j omega, tan inverse of imaginary part by real part, tan inverse of omega by 1. So tan inverse of omega. Next, angle of 2 plus j omega, tan inverse of omega by 2. Tan inverse of omega by 2. So let me write the phase equation. Let me take it to numerator. Minus 90 degree minus tan inverse of omega minus tan inverse of omega by 2. So this is the phase equation. So we got magnitude equation, phase equation. Next, this table should come. It should come actually here. So let me, anyhow I taken here, let it be here only, no problem. So okay, how to calculate magnitude? Omega equal to plus infinity, substitute here. So substitute omega equal to infinity in magnitude equation. So I should get here, what I should write? Magnitude m at an angle phi. So for omega equal to plus infinity, I should calculate what is the magnitude and what is the angle. So first substitute plus infinity here. So anything divided by infinity is 0. So magnitude is 0. Next, calculate, substitute omega equal to plus infinity in phase equation. So minus 90. Tan inverse of infinity is 90 degree, right? Tan inverse of infinity. So minus 90, minus 90, minus 90. Minus 90, from this minus 90, minus 90. So minus 270 degree. So I am getting, I hope you are understanding, right? So omega equal to plus infinity, substitute here. Omega equal to plus infinity. Tan inverse of infinity is 90 degree, right? So tan inverse of infinity is 90 degree. So minus 90 degree, minus 90, minus 90. So it is minus 270. Next, for terminating point, frequency is omega equal to 0. Substitute omega equal to 0 and magnitude equation. Anything divided by 0 is infinity. So this is the magnitude. Calculate the angle. So substitute omega equal to 0 and phase equation. So tan inverse of 0 is 0. This is 0. So I am left out with minus 90 degree. I hope you are getting. The next, rotation of plot. Rotation of plot. This we have seen already how to draw the polar plot. Same thing I am following here. So you have to subtract like this. Terminating point angle to starting point angle. So minus 90 degree minus of open bracket minus 270. So how much I will get? So minus 90 minus into minus plus 270. So I am getting 180 degree. Okay, I am getting plus 180 degree. So what should be the rotation of the plot? 180 degree. Rotation is rotation of plot is 180 degree. In which direction? Clockwise or anti-clockwise? If it is plus means anti-clockwise, right? So 180 degree in anti-clockwise direction. Rotation is 180 degree in anti-clockwise direction. Because plus is there. If I am getting minus 180, it is clockwise, right? Since plus 180 I am getting, rotation is 180 degree in anti-clockwise direction, because anti-clockwise we will take it as positive, clockwise we take it as negative, right? Next, we can draw now with this information. I can draw the polar plot, right? So let me keep it pending. I will not draw the polar plot because let me keep it pending, because other sections are also there. Section 1 is over. Next, let me come to the section 2. I will not draw the polar plot for section 1. I have all the data, right? Let me keep it ready. Section 2. So what is the starting point for section 2 and terminating point for section 2? We'll see. Observe here, plus j0 is the starting point, minus j0 is the terminating point. Plus j0 minus j0, plus j0 minus j0. Okay, we will make the table. Already we have the magnitude equation, phase equation, the same equations we will going to use, right? Once again we will not write magnitude and phase equations. Then I will make this table, starting point and terminating point. Starting point, terminating point. So starting point, what is omega? Plus 0. And what is omega for this? Minus 0, terminating point. Is it fine? Then next, we should calculate magnitude and phase. Let me calculate. I have left blank. Then rotation of plot. Right, we'll see all those things. Okay, you can observe here, starting point of this is nothing but the terminating point of section 1. This is plus j0. This is the terminating point. Here it is starting section. So already we have calculated magnitude. It is infinity and minus. No need to calculate. Directly you copy this. Infinity and minus 90 degree. Angle is minus. No, don't calculate once again. Because the starting point of section 2 is nothing but the terminating point of section 1. So for terminating point, it is magnitude is infinity, angle is minus 90. So write it. Then observe here, don't calculate once again using this magnitude and phase equations. So if it is plus 0 and exactly minus 0, whenever there is a semicircle like this here, if the angle is infinity and what we got, it will be exactly opposite, right? Magnitude is same, but phase will be reverse. If it is plus 270 here, it will be minus 270 here. If it is plus 90, it will be minus 290, minus 90, right? But magnitude will be same. If it is plus infinity here, also it is plus infinity. So don't substitute in these equations and calculate. You will go wrong. If you calculate, you will go wrong. Please keep in the mind. I am stressing a lot. Don't substitute. The terminating point is the starting point for section 2. So copy this magnitude and angle. This one I have copied there, right? Then for semicircle, because this is the semicircle, right? So magnitude remains the same. This infinity, copy it as it is. But angle, if it is minus 90 here, it will be plus 90. So if it is minus 90 here at this point, so it will be plus 90, exactly opposite. Please keep in the mind, right? Don't calculate. Next, we will calculate the rotation of the plot. Don't substitute these values omega to plus 0 and minus 0 in magnitude and phase equations. You will go wrong. Please, I am stressing a lot, right? Next, calculate the rotation of plot. So we will subtract plus 90 degree minus of minus 90 degree. This is minus 90 degree. So how much I will get? So minus into minus plus. So 180 degree. Once again I am getting. Right? I hope you are getting. So 180 degree. Rotation of plot is rotation is 180 degree in anti-clockwise direction. Anti-clockwise because it is positive. Anti-clockwise direction. Okay, with this information I can draw the polar plot, but I will not do it because I will draw the polar plot of all the sections at a time, right? So I will not do it, right? Next, section 3. Come to section 3. Section 1 is over. Section 3. I will not draw the polar plot for section 3 because section 3 is mirror image of section 1. Section 3 is mirror image of section 1. So just I will write here section 3. I will write it here. So section 3 is mirror image of section 1. For this comment I will write, but I will not calculate the starting point, terminating point. I will not take because section 3 is mirror image of section 1, right? The polar plot will be mirror image of section 1, whatever we get, right? So that much. Then come to the last section, section 4. For last section, we will not draw the polar plot because it represents origin in the Nyquist plot. So I will write here section 4. Since it is the last section, it represents origin in Nyquist plot. It represents origin in Nyquist. This is very important, right? So I will not draw polar plot. Next, I have all the sections. Now I can draw the polar plot. But before drawing the polar plot, whether the polar plot intersects the negative real axis. If it intersects, then I have to find out the intersection point. Let me draw a rough polar plot here for Nyquist plot. Rough. It is not exactly rough. I will draw. Let me draw it rough here only. Next, I will go to step 5 because this is step 4, I think. Yes, step 4. We are in step 4. Step 5 is if the Nyquist plot is intersecting negative real axis, then I have to find out omega PC, all those things, right? So I'll draw the polar plot here. Just try to observe. This is rough I am drawing. Sigma j omega. Okay, what is first section? Section 1. So it is magnitude is here. Observe here. Omega equal to plus infinity to plus 0, right? So what is minus 270 degree line? Magnitude is 0. So let me draw 0 degree, minus 90 degree, minus 180 degree, minus 270 degree. I hope you are getting. If I come in clockwise direction, 0 degree, it is plus 90. This one is plus 180, plus 270, 360, right? If I go in clockwise direction. So this is plus 90. Or else it is minus 270 if I come in clockwise direction. So let me represent here. Okay, for section 1, minus 270, magnitude is 0. Minus 270 is here, magnitude is 0. It will come here. I'll look at the point. Next, for section 1, terminating point, minus 90 degree, infinity. Minus 90 degree is this line. Let me look at infinity here. Infinity, I can take it here also, no problem. I'll take it. Let me assume that infinity is here. But actually infinity means it was never ending, right? Let me take it here. So this is omega equal to infinity and omega equal to 0. Omega equal to 0 here. And what is the rotation of the plot? It is 180 degree in anti-clockwise direction. 180 degree in anti-clockwise direction. If I draw it like this, it is 90 degree clockwise. Means this should come like this. 90 degree here, another 90 degree here, 180 degree. This is an anti-clockwise, right? Anti-clockwise direction. So 90, from here to here it is 90 degree clockwise, from here to here 90 degree. So totally 180 degree clockwise. Section 1 is over. Section 1 polar plot is over. Next come to section 2. Section 2, here it is, observe here, minus 90 degree. Starting point, minus 90 degree, it is infinity. Minus 90 degree infinity is here, right? Because the terminating point is the starting point for section 2. It is here. Next come to this. Plus 90 degree infinity. Plus 90 degree means here. Plus 90. It is minus 270 or plus 90, right? So plus 90. What is the magnitude? It is infinity. So we are located infinity here. At same location you look at infinity here. I have located this for section 2. Then what is the rotation of plot? 180 degree in anti-clockwise direction. From here to here 90, 90, 180. So draw it. For section 2, this is the polar plot for section 2. I hope you are getting, right? Any doubts, please unmute yourself and talk to me so that I can clarify. So omega equal to 0, omega equal to here, omega equal to minus 0. I hope you are getting. For section 1, this is the polar plot. For section 2, this is the polar plot. Then for section 3, what I have written, what comment I have written? Section 3 is mirror image of section 1. So this is a section 1 polar plot. Mirror image means it should be like this. So mirror image I'll draw it. Observe here. Let me draw the mirror image. No need to change the color, but let me change the color for your reference. So it should be mirror image exactly. Right? I hope you are getting. So it will come here. It will come here. See, it starts here. This is section 1 polar plot, section 2 polar plot, section 3 is mirror image of this. Mirror image about real axis. It is mirror image. Exactly right. Then section 4, it represents origin. Origin is here, right? It represents origin in the Nyquist plot. No need to draw. So this is the rough Nyquist plot. But this is rough. And you can see here, this Nyquist plot is intersecting the minus 180 degree line. Reference line means I will get point Q here. So here omega equal to omega PC. What is omega equal to omega PC? I have to find out. And what is the coordinate of point Q? I have to find out. Because Nyquist plot is intersecting the negative real axis. So I have to calculate the omega PC value and the coordinates of point Q. And this is the origin. Okay, that is step 4. I hope this rough Nyquist plot I have drawn. Rough Nyquist plot. This is not exact because I don't know the coordinates of point Q. Whether it is minus 1, I don't know, right? I have to calculate the coordinates. So we'll go to step 4 is over. Next we'll continue with step 5. Step 5, determine omega PC mathematically. Omega PC mathematically. Okay, next we'll see the how to determine omega PC mathematically, and also find coordinates of point Q. Coordinates of Q. Just I'll write Q. What is Q? You know here, right? This intersection point. What are the coordinates and what is omega PC? Both we have to calculate. Okay, how to find out omega PC? We know. Rationalize. First, what is g of j omega and h of j omega will take. Let me write it here. So it is 10 divided by j omega. 10 divided by j omega into 1 plus j omega into 2 plus j omega. So first step is the rationalize it. So 0 plus j omega means 0 minus j omega will come. I will not write 0. 1 plus j omega means 1 minus j omega. 2 plus j omega means 2 minus j omega. But mathematically if I keep this much, this is wrong. So take the same thing in the denominator so that I will get back g of j omega and h of j omega. It will not affect mathematically. It will be correct. So rationalize it. Okay, just you will multiply all those things. And one more thing you keep in the mind, j into j is j square and it is equal to minus 1. Please keep in the mind before multiplying, right? We'll multiply the things. What I will be getting, g of j omega. After rationalizing, what we have to do, we have to multiply and we have to separate it into real parts and imaginary part. We'll do that. So observe here. First I will multiply these two things. Okay, let me see it. Okay, let me multiply these two things. This one and this one. Let me write it here. 1 into 2 is 2. 1 into minus j omega is minus j omega. Then minus j omega into 2. Minus 2 j omega. Minus into minus it is plus, right? But j omega into j omega. Minus into minus it is plus. J into j square. Once again I will get minus. J square is minus 1 I told already, right? So minus into minus it is plus. But j into j is j square. It is minus 1. Omega into omega is omega square. I hope you are getting after multiplying these two things, right? And I am left out with minus j omega should be multiplied for this. Okay, fine. Minus j omega, we will keep it. Minus j omega minus 2j minus 3j omega, right? So let me write it. Real part separate. 2 minus omega square. Minus j omega minus 2j omega minus 3j omega. Real part, imaginary part. But I have to multiply once again this one. Let me multiply. I hope it is correct. If I am making any mistakes, please correct me, right? Minus 3j omega is correct. Let me multiply. Minus j omega with 2. Minus 2j omega. Then this one. Minus into minus it is plus j omega cube. I will get, I think, right? J omega cube. Or else let me keep it this much. Let me see if anything is possible. Or else let me multiply first entire thing. Okay, let me multiply, no problem. Okay, let me multiply, no problem. Minus into minus plus j omega cube. Next minus into minus plus, but j into j will be j square. It is minus to minus plus. Once again it will be minus. So j into j is j square. It is minus 1. So 3 omega square. 3 omega square. So let me separate real part and imaginary part. This is real part and this is imaginary part. So minus 3 omega square is real part and imaginary part. Let me take plus j omega common, right? Plus j omega common. If I take plus j omega common, what is the thing? What I will be getting? Omega. If I multiply, I am getting j omega cube minus 2. So minus 2 j omega I am getting. So let me write in the numerator what I am getting. So this I have entire thing I have multiplied. But this 10 is there. Keep it. Right? This 10 has to be kept. So 10 into minus 3 omega square plus j omega into omega minus 2. Right? I got this. Next. Okay. We have to multiply the numerator part is over. Next denominator. 0 plus j omega into 0 minus a plus b into a minus b formula I will apply. 0 plus j omega or else multiply directly. See here. J omega into minus j omega. J omega into minus j omega. What I will be getting? Check it. A plus into minus is minus, but j into j square is minus, so I will be getting plus, so omega square. Simply I will get omega square if I multiply these two, this and this, so I will get omega square. I will write it here. Next I will multiply 1 plus j omega into 1 minus j omega, a plus b into a minus b. So I will be getting a square minus b square. This is rough work I am doing here. A square means 1 square minus b square. This entire thing. B minus b square means j omega whole square. A square minus b square, right? So a square minus b, j square is minus 1, so it will become plus, so 1 plus omega square I will get. So this and this and this, I am getting 1 plus omega square. Next, let me multiply this and this. So 2 plus j omega into 2 minus a plus b into a minus b, a square minus b square. A square is 4 minus b square is j omega whole square. So what I will be getting 4, j square is minus 1, so minus 2 minus plus 4 plus omega square I will get. So we have multiplied denominator. So this we are getting. Next we have to separate it into real part and imaginary part, right? So let me call this denominator, entire term. Let d is equal to, no need to call, but let me, you can write it. It will simplify our job. Omega square into 1 plus omega square into 4 plus omega square. This the entire denominator I have called it as d. This entire denominator, right? Then I will write it. Let me separate it into real part and imaginary part. Separate into real part and imaginary part. Okay, time up. Let me take another 10 minutes extra. I will request Ravi Shankar sir, no problem. I will request. I will ask apology also, but let me finish this, right? I will call sir and I will request him. Separate into real part and imaginary part, right? We'll separate it. J of j omega into h of j omega, right? So this numerator term is there. So this is real part and this is imaginary part. Let me multiply minus 30, 10 into 3, minus 30 omega square divided by d. This entire thing is d, right? So this divided by this denominator plus j, imaginary part, omega into omega minus 2. Is it correct? Yes. Omega into omega minus 2 divided by d. I hope you are getting. So we are separated into real part and imaginary part, right? Call this as equation 1. Then since at this point q, imaginary part is 0 because I am getting coordinates minus sigma plus j0. Imaginary part is 0. So equate imaginary part to 0. Equate imaginary part to 0. So let me equate imaginary part to 0. Imaginary part means only this much. So omega into omega minus 2 divided by d equal to 0. So omega into omega minus 2 divided by d equal to 0, which implies d, if I take this side, omega into omega minus 2 equal to 0. So what I will be getting? Omega equal to 0 and omega equal to 2 values I am getting. Omega equal to 0 and omega equal to 2. But what should be the omega value? So this omega equal to omega pc here, phase crossover frequency. So it cannot be 0 because it has to be positive, finite and greater than 0. So omega equal to 0 is invalid because it is not greater than 0, it is equal to 0. So whatever the value of omega I am getting, it should be positive, finite and greater than 0. So omega equal to 2, that is the fine, right? I think I have made somewhere mistake, I think. What is that mistake? Can anyone tell?
J omega into omega square minus 2, sir.
J omega into omega square minus 2, right?
Yes, sir.
That I don't know where I have made mistake here. Omega square, how it will come? Where I have made mistake here?
Here we'll get J omega cube.
j omega cube. Here I have written somewhere. Here I think, right? Minus 3 omega square plus j
Yes,
omega.
sir.
Omega square minus 2. Yes, here. Omega square minus 2. Yes. Omega square. Please correct it. Omega square, omega square, omega square. And omega square minus 2. Omega equal to 0 and omega square minus 2 equal to 0. So I will get omega square equal to 2. So which finally I will get omega equal to root 2. So omega equal to 0 is invalid because omega should be positive, finite and greater than 0. So omega equal to root 2. So what is the omega PC value? Omega equal to omega PC, and that is equal to root 2. We will discard this 0 because whatever the value I get, it should be positive, finite and greater than 0. This condition, it should be satisfied. So omega equal to 0 is not satisfying that condition, but root 2 is satisfying. So this is omega PC value we have found out. So we came to know root 2 radians per second. But what is that step? Determine omega PC. Yes, we have done. And find out the coordinates of point Q. We have to find out the coordinates of point Q. Means substitute this value of omega PC. Substitute this value of omega PC in real part. Real part. So real part is here. This one. Equation 1. Right? So real part is minus 30 omega square by D. Real part. Real part is equal to minus 30 omega square by D. What is that D? I have to substitute. Minus 30 omega square divided by D is nothing but omega square into 1 plus omega square into 4 plus omega square at omega equal to omega PC. That is equal to root 2. I have to substitute wherever omega is there. I have to substitute root 2. So we will substitute here minus 30 into omega square. What is omega equal to root 2, right? And omega square is 2. So omega square means 2. I am substituting, that's all. So omega square is 2 into 1 plus omega square is 2 into 4 plus what is omega square? It is 2. So we will calculate how much you will get. 30 into 2 60 divided by 2 into 2 plus 1 is 3 into 4 plus 2 is 6. So let me calculate minus 60 divided by 3 2 ja 6 6 6 ja 36. So let me calculate how much you will get. So 60 divided by 36. So I am getting minus 1.66. So this itself is coordinate of point Q. Coordinate of point Q. Point Q is minus 1.66. If you want to write imaginary part plus J0, you can write. So I have found out. So here let me draw the need sketch, right? I hope step 5 is over. Next step 6, we will come to step 6. Step 6. Using the information in step 5 and 4, we will draw the Nyquist plot. Draw the Nyquist plot. Draw the Nyquist plot. Okay, we'll draw the Nyquist plot. So where the poles are located, let me locate. 0, minus 1, minus 2, right? 0, minus 1, minus 2. 0, minus, this is 0. Minus 1, let me take it here. And minus 2 is here. And critical point. What is critical point? Sigma at j omega. 0 degree, minus 90, minus 180, minus 270. If I go in clockwise, anti-clockwise direction, this is 0, 90 degree, and this is 180. I will not write, but this I require, so I am writing 0, 90, 180, 270 like this, right? I hope you are getting. Next, I have located and critical point. What is critical point? Critical point. Please concentrate on critical point. It is minus 1 plus j0. This one, minus 1 plus j0 here, right? Let me write it. Minus 1 plus j0. This is critical point, right? Here at the same point. Okay, we will draw the polar plot. Rough sketch we have drawn. Here, rough sketch. This will help us. So it should intersect at point Q. Q is minus 1.66. Minus 1.66, somewhere it will come here. Minus 1.66. This is point Q, right? So it should intersect here. at this value, right? So it will come and intersect at point Q and it will go to infinity. So infinity will choose here. Let me take infinity here, right? So let me draw the Nyquist plot. Let me change the ink color. So it will go and intersect at infinity here because I've taken infinity here, right? So this is the direction. Direction is very important, right? So look at this rough sketch already ready. Next, plus j infinity, it will go like this. So at this distance means, let me take this here. Let me extend this. So from here to here, distance same take. You take same distance here, and we'll draw the D shape. So next, mirror image. Okay, I hope you understood. The rough sketch is ready here. Rough sketch we have drawn here, but we have taken point Q into care, and critical point also we have considered. So minus 1.6 is here. My critical point is here. Just observe, right? Step 6 is over. Nyquist plot. This is Nyquist plot. Next, step 7. Step 7. Okay, I don't have. Okay, let me write it here only. Step 7. I don't have one more PPT. Let me write it here only. Step 7. What is step 7? What number of n circumference n I have to find out. What is n? We have to calculate. So in order to calculate whether, okay, this is the critical point. Minus 1 plus j0 is the critical point. Minus 1 plus j0. It is enclosed. It is sure. But how many times it is encircled? We have to check it, right? So let me take one point here outside this Nyquist plot and let me join it here. Let me join it. Let me use some other ink. Let me join it. Okay, you can take point here also and you can draw like this, but don't take point here on this negative and draw it like this because it is confusing. Because, right, it should intersect here. I am getting two encirclements, roughly I can say two, but let me check it, right? So at this point it is intersecting, so it is in this direction, anti-clockwise direction. So I will make it, so it is how much for at this point. So it is in anti-clockwise means plus how many times? One time. Take the intersection at this point, so it is in this direction, anti-clockwise direction. So take this, so it is plus anti-clockwise direction. How many times? One. So total n is how much? Add this and this. So plus 1 plus 2. So n equal to plus 2 I am getting. So let me go back. So n equal to plus 2 I am getting, means the Nyquist plot is enclosing the critical point two times. So let me write it. Nyquist plot is encircling circling critical point minus 1 plus j0 twice. Twice means two times. Critical point two times. In which direction? In anti-clockwise direction. In anti-clockwise direction. In anti-clockwise direction. But go to step 2. What is the stability condition? In step 2 it is telling n should be 0. If n is 0, then system will be stable. What value of n I am getting here? I am getting n equal to 2. Since stability criteria is not met, as in step 2, since stability criteria that is, what is stability criteria? Nyquist stability. Since Nyquist stability criteria n equal to 0 is not met, because n equal to 2 I am getting, right? But n should be 0 for system to be stable. So since Nyquist stability criteria n equal to 0 is not met here, so system is unstable. Yes, we got it, right? Then next, this is over, problem is over. But if it is asked to find out gain margin, how to find out? I'll tell you, right? This is over, we have proved how to find out. To find gain margin, so we know the equation. Gain margin is equal to 1 by magnitude of OQ. So 1 by What is this? Is origin O and Q is here. So what is the magnitude? Well, it is 1.66 minus 1 point magnitude is 1.66, 1 by 1.66. So if I want in decibels in dB, so gain margin is 20 log of this quantity 1 by 1.66. So you calculate this, how much you will get, you tell me. So 20 log of 1 divided by 1.66. So I am getting minus 4 point, yes, I am getting negative value. You can observe here, minus 4.402 dB decibels. And you can observe here gain margin is negative. Since gain margin is negative, so given system is unstable. This is another way. But problem is over here itself. Since gain margin is negative, so given system is unstable. Okay, this completes the Nyquist plot. Any doubts? Please try to practice the same problem once again. And if any doubts, please get back to me and we will solve few more numericals on this Nyquist plot in the next class. Okay, thank you. Thank you.